Hey everybody, Jeff Oriema here, and I'm here to tell you that if you're operating an MCP server, you just saved some money. MCP is now a stateless protocol. That meant a lot to me as a spec nerd, but it just hit me that this has real economic impact. The July 28th, 2026 spec removes the initialization handshake, the Mcp-Session-Id header, and the protocol session that connected them. So, unlike something like language server protocol, MCP no longer requires that first transactional step. This has implications for your platform architecture that could save you money. In previous versions, an MCP client began by calling initialize. That request negotiated the protocol version, exchanged information about the client and server, and established their capabilities. When a remote server created a session, it returned an Mcp-Session-Id, and the client included that ID with every request that followed. The model resembled a traditional server-side web session. A browser receives an opaque identifier and a cookie and sends it back so the application can recover the correct state. MCP used a dedicated header, but server infrastructure faced the same question. What happens when the next request reaches a different server? A load balancer could pin each client to the instance that created its session. That works until an instance disappears, traffic becomes uneven, or if you just want to deploy a new version without disrupting active clients. The other option was to move session state into a shared infrastructure, such as Redis. Every server could then recover every session, though every request might now require another network hop just to reconstruct the protocol context around the tool call. This is the kind of architectural tax that can remain invisible while an MCP server is running on a laptop. It becomes part of the bill once that server is offered remotely to thousands of clients. Someone has to operate the session store, configure sticky routing, expire abandoned sessions, handle reconnections, and decide what happens to active clients during scaling events and deployments. GitHub's MCP server provides a useful production example. Its migration to the new protocol removed Redis sessions entirely. That eliminated a database write during initialization and a database read on every subsequent call. GitHub also stopped inspecting each JSON RPC payload to find information needed for logging and secret scanning because the new protocol exposes the MCP method and toolname in standard HTTP headers. Their summary is that calls became faster without users losing anything at all. The new request model is self-contained. Protocol version and client metadata travel with the request that needs them. Clients can use server/discover when they want the server's capabilities up front, but they can call a tool without first establishing a long-lived protocol relationship. A plain round-robin load balancer can send each request to any compatible instance. Application state still exists where the application needs it. A browser automation server can return a browser ID, and later tool calls can include that ID as an ordinary argument. A shopping tool can do the same with basket ID. Those handles may point to durable server-side state, which still needs to be stored and operated. The team pays that cost because its workflow requires a persistent browser or basket, rather than because every MCP connection automatically creates a session. For infrastructure teams, this opens up much more ordinary deployment patterns. Instances can be added during a traffic spike, removed during scale down, or replaced during a rolling deployment without migrating protocol sessions. Stateless tools become a better fit for serverless platforms and scale to zero deployments. Failure recovery also becomes simpler because the next request can land elsewhere without rebuilding its MCP session first. Web engineers benefit from the same change. An MCP endpoint can sit behind the load balancers, gateways, rate limiters, and auto-scaling systems they already use for HTTP services. A simple search tool can remain simple. A stateful browser tool can introduce storage deliberately, and the protocol no longer pushes both of them toward the same infrastructure. So yeah, MCP went stateless. That may eliminate the need for any or all of these nodes on your architecture diagram. Sticky routing, session databases, session expiration, and the reconnect logic that goes along with them. So as this change gets supported by the major implementers, we can expect MCP to get easier to deploy and recover, and cheaper to scale. For more videos on MCP and other parts of the AI and API ecosystem, subscribe to the channel. Drop a comment while you're there. That's it for now. See you next time.